In this video, we're going to look at a quick example of solving an absolute value inequality.
Hi, everybody. So I want to take some time here to answer a question that I got about an absolute value inequality. And so the inequality that we got was 2 times x minus the absolute value of x minus 3 is greater than the absolute value of 3x plus 1. Now, the first thing I want to do here is recognize that the behavior of the absolute values depends on what domain we're looking at. So, for example, for this left-hand side here, x minus 3, we've got this absolute value of x minus 3. Okay, notice that x minus 3 is equal to 0 at 3. So we're going to mark off 3 on the number line here. If we pick numbers or values of x that are greater than 3, then x minus 3 is actually going to produce a positive number. And so I don't need to worry about it. I don't need to do anything to it. But if I choose values of x less than 3, x minus 3 will become negative. And so to balance that, I have to put a negative in front of it to make it positive, okay? Because that's what the absolute value does. Now let's take a look at this 3x plus 1. Okay, well, 3x plus 1 is going to equal 0 when x is equal to negative 1/3. I'll bring the 1 over, divide by 3. So I'm going to mark that off over here, negative 1/3. If I choose values of x larger than negative 1/3, I don't have to do anything to 3x plus 1. It will become positive. But if I choose a value of x less than negative 1/3, then 3x plus 1 is going to be negative. And so what I have to do is throw a negative in front of that to make the value positive. Okay, and that's what the absolute value does. So now, when I answer this question here, okay, when I approach this inequality, what I have to do is I have to look at it in the 3 different regions that I've just outlined here. So to the left of negative 1/3, what happens here is the absolute value of x minus 3 needs a negative in front of it, okay, because its values are naturally going to be negative, so I have to make it positive. Greater than, well, 3x plus 1, the absolute value of 3x plus 1 forces a negative in front of that expression. And so now I'm going to solve this inequality. I'm going to multiply through by negative 2. So negative 2x plus 6 is greater than negative 3x plus 1. I'm going to bring the 3x over, and I will get just x because I'll have to add that to both sides, and there's a negative 2 there. I'm going to subtract the 6 from both sides. Oh, no, I'm sorry. I forgot I didn't put the negative through, so there's going to be negative 1 there. So when I bring the 6 over, it'll be greater than negative 7. And bear in mind that that's the solution to this inequality, but I was in a region here where x was less than negative 1/3. So, and actually, I can include the negative 1/3 here. With the definition of the absolute value here, I can include that endpoint in that. And so now I know that my solution here, this is going to work if I pick values of x that are greater than negative 7 and less than or equal to negative 1/3. Okay. And the reason I can include that endpoint there is because if I plug negative 1/3 in, I'm going to get a 0 there. And that's okay. That works. Okay. Now, if I go between negative 1/3, if I choose a value of x between negative 1/3 and 3, and I'm going to include the endpoints again, because with the absolute values, it's just going to 0 at those endpoints, so I can include that. What that means is the left-hand side, that absolute value of x minus 3, I'm going to need to alter that because I'm still to the left of 3. So this is going to be 2 times negative x minus 3. But the right-hand side doesn't need to be altered because it will automatically be positive. So again, this will be negative 2x plus 6 greater than 3x plus 1. Bring the 2x over and I get 5x on the right-hand side. Bring the 1 over and I get 5. And so this is going to be x is less than 1. Now, bear in mind, though, that's between negative 1/3 and positive 3. So that actually works because as long as I go from negative 1/3 up to 1, that is going to hold here. Those two intervals overlap. My solution that I figured out and the interval that I'm working in overlap. Now, on the right-hand side of 3, both of these expressions, or I should say neither one of these expressions, require any kind of editing here. So it's going to be 2 times x minus 3 greater than 3x plus 1. So 2x minus 6 greater than 3x plus 1. So I'm going to bring that 2x over. Whoops. And that's going to get me just the x over here. And I'll bring the negative 1, sorry, the 1 over becomes negative 1, so negative 7. So I'm going to get an answer of x is less than negative 7. Now, the thing is, I'm getting this answer of x is less than negative 7 in a region where I know that x is supposed to be larger than 3, greater than or equal to 3. So these two intervals here aren't jiving. My solution isn't jiving with the restriction that I'm working in. So there's going to be no solution coming from this particular region here. So I'm just going to take a look at the intervals that I did get. I got an answer of negative 7 is less than x is less than or equal to negative 1/3. And then negative 1/3 is less than or equal to x is less than 1. So my overall solution is going to be from negative 7 out to positive 1. And this is the overall answer to this inequality, this absolute value inequality. Now, what I want you to kind of gather from this is when you're dealing with an absolute value inequality, one of the things you can do here is break up the number line into the regions where the definitions of the absolute value or how you apply the absolute value changes. So basically, you're looking for where those things go to 0. And on one side, you're going to have to include a negative. On the other side, you're going to have to include a positive. Then what you do is you break this inequality up into a number of questions kind of equal to those regions, and you apply the negatives in the regions where they apply, solve it, and just make sure that your solution matches in some way or another with the interval that you're working in. Okay, I hope that makes sense.